This is a brief history of weather and climate control. My name is Jim Fleming. I'm a professor of science, technology, and society at Colby College, a visiting scholar at Columbia University, and a historian of science and technology. And I've written extensively on the history of weather and climate. I attend a lot of geoengineering meetings, but now that term geoengineering is considered passé. First of all, it's not engineering. It's speculation done mainly through back-of-the-envelope calculations and Rube Goldberg-like inventions and relatively simple climate models that are not predictive. The term is rapidly being replaced in two ways. First, by a relatively good idea, that is, capture and store our carbon dioxide emissions safely. And two, by a very sketchy idea, intervene in a heavy-handed way in the solar radiation budget, for example, by injecting sulfate particles into the stratosphere. Today I wish to argue that history matters and that fixing the sky through weather and climate control is not a new idea, but it has a long and checkered history. And that's actually the topic of my book, Fixing the Sky, which I'll be telling you about excerpts in a few minutes. Now, the following claims were made recently by very prominent speakers. Quote, "We don't have a history of climate control to fall back on," end quote. Well, yes, we do. Another speaker, quote, "Things are moving quickly. We don't have the luxury of looking at history." Well, it really takes about 3 or 4 hours to get a little bit of a background in this, even shorter, as I'll try to present today. A third quote, "We are the first generation to think about these things." No, as I'll show again, history says otherwise. Visionary schemes for weather and climate control have a long history, but with a very few exceptions, they have never worked. Would-be climate engineers and policymakers need to take this into account. My intent here is to demonstrate that contrary to claims that climate engineering is something wholly new in scale and intent, a number of previous technological inventions have been attempted on the atmosphere on both regional and planetary scales. By and large, they did not have their desired effects. On the physical environment, they outpaced their original technical requirements, and they gave rise to complicated political, social, and economic issues. That is, technological fixes usually have unintended consequences. I would like to address the claim that weather modification has little to teach us about climate control. Weather control and climate control are intimately related, in fact. Weather and climate are on a continuum of scales, so any intervention in the Earth's radiation or heat budget, such as managing solar radiation, would affect the hydrologic cycle and the general circulation, thus rainfall and upper-level wind patterns, including the location of the jet stream and storm tracks. So intervening in the climate would be an intervention in weather systems. The weather itself would be changed by such manipulation. Conversely, intervening in severe storms by changing their intensity or their tracks, or modifying the weather on a large scale, such as a region or a continent or an ocean, would obviously affect cloudiness, temperature, precipitation, with major consequences for monsoonal flows and ultimately the general circulation. That is, the climate statistics would be changed by weather control done consistently or on a very large scale. These interventions would influence the overall heat budget and thus the climate. Now some history. The earliest documented cases of rainmaking tend to be regional rather than global, but are still on a very large scale. In 1841, James Espy, America's first national meteorologist, developed a theory of storms powered by convection. But the so-called Storm King went off the deep end, technically, when he proposed lighting giant fires all along the Appalachian Mountains to emulate an artificial volcano that he thought would generate rains, disrupt cold and heat waves, and clear the air of miasmas. His contemporary, a writer named Eliza Leslie, perceptively pointed out that attaining such control might cause serious damage to social relations. There were many other such rainmaking schemes, and I'm going to move quickly now. In the 1920s, with concerns about aviation safety ascendant, independent inventor L. Francis Warren and Cornell chemistry professor Wilder Bancroft developed a scheme to dose the clouds with electrified sand. delivered by airplane. Rainmaking and fog clearing were both on the agenda, but trials supported by the U.S. Army Air Corps were less than promising. It turned out that airplanes could successfully disrupt smaller clouds for experimenters, but they could not predict whether a treated cloud would subsequently dissipate or thicken. These early weather modification plans, some of surprisingly large scale, were couched in the context of the pressing issues and available technologies of their eras. Espy wanted to purify the air and make rain for the East Coast, and Bancroft and Warren hoped to make rain and clear airports of fog, while the military sought advantage for its flyers. But intervention is not control, and the hype surrounding both projects exceeded technical capabilities. Prospects for larger scale, even planetary intervention in the climate system arrived after 1945, with the dawn of several transformative technologies, namely nuclear weapons, digital computing, chemical cloud seeding, and access to space. Two of the projects that I'm going to discuss involved cloud seeding techniques, and two involved disruption of the space environment. In 1947, scientists at the General Electric Corporation developed methods for seeding clouds with dry ice and silver iodide, and they sparked a race for commercial applications and military control of the clouds. They partnered with the military and Project Cirrus to seed an Atlantic hurricane with dry ice, but this experiment went awry. Nevertheless, GE chief scientist Irving Langmuir hyped the possibilities, arguing that hurricanes could be redirected and the climate might ultimately be controlled on a continental and even oceanic scale with the techniques they had developed. But as his colleague Kathleen Blodgett at General Electric told Irving Langmuir, you can intervene in a cloud, but you cannot control it. As cloud seeding reached around the world, especially into arid areas and upslope watersheds, it never resulted in fully reliable techniques to enhance precipitation or snowpack. The scale of nature was just too huge, and the problems of verification and social acceptance were also quite large. Instead of quasi-military aerial bombardment of the clouds, small-scale practices such as drip irrigation and snowmaking machines became the norm. Between 1966 and 1974, massive and surreptitious seeding of the Southeast Asian monsoon during the Vietnam War resulted in literal measurable rain, but in a diplomatic nightmare for the United States when the Soviet Union brought the issue of environmental warfare to the attention of the United Nations. The UN Convention on the Prohibition of Military or any other hostile use of environmental modification techniques, ENMOD, was the biggest fallout from the effort, followed by a systematic and persistent collapse of U.S. federal support for cloud seeding. Now on to some nuclear issues. The Argus and Starfish Prime nuclear detonations in space. Argus was in 1958, and it was an attempt to disrupt the magnetosphere with 3 atomic bombs in the South Atlantic. And Starfish Prime was in 1962, a giant hydrogen bomb explosion, again in the magnetosphere. They were actually attempts to geoengineer the planet. There were Soviet tests as well that were very similar. It was based on a theory promulgated by Nicholas Christophilus, a physicist at Lawrence Berkeley Labs, who held that the ionized debris and high-energy electrons generated by a nuclear explosion would travel almost instantly through the Earth's magnetic field as a giant current. In case of hostilities, which were quite possible at the time, a nuclear blast could possibly generate a massive electromagnetic pulse, an EMP, over an enemy city, disrupt military communications, and destroy both satellites and electronic guidance systems of enemy missiles. These tests, which were conducted by both superpowers, generated widespread public outrage and were quickly followed by the Limited Test Ban Treaty of 1963. Now for some synthetic lessons from history. History teaches us that things change, often in surprising or unanticipated ways, and that a certain amount of clarity can be gained by looking backward as we inevitably rush forward. I'm an expert in history. I think we're all amateurs in the future, but history provides some perspective. Schemes aimed at attempted control of weather and climate, often framed as responses to critical problems of the day, such as water shortages, military exigencies, and Cold War dominance, have fallen short of their goals many times in the past. The checkered history of this field provides valuable perspectives and a cautionary warning on what might otherwise be seen today as completely unprecedented climate challenges. Contemporary engineers err if they ignore their own history. Would-be climate engineers are strongly motivated today by fears of future global warming, but within recent memory, this landscape too has been changing. The past decade and a half of surface temperature measurements seem to indicate the estimated sensitivity of the climate to increasing greenhouse gases is somewhat less than models have projected, temporarily reducing some of the short-term angst. Additionally, there is strong technical resistance, or at least caution, from the faculty of mainstream atmospheric science departments who tend to be quite skeptical of simple climate engineering schemes. Increasingly, historians, philosophers, and other humanists and social scientists are getting beyond back-of-the-envelope technicalities and are taking a critical look at complex issues related to the history, ethics, and governance of global climate control issues. Even the neologism geoengineering is in the process of being abandoned, since it's not really engineering in any traditional sense, as is the phrase solar radiation management, since there are too many unknowns to really consider it a form of management. Intervention into weather and climate systems does not result in control over them. Instead, it has given rise to unexpectedly complicated social issues. In Vietnam, in the Cold War, and today it's still quite a tangled social conversation. We should base our decision-making not only on technical expertise and what we think we can do now and in the near future. Rather, our knowledge must be shaped and tempered by what we have and have not done in the past. Such are the grounds for making informed decisions and avoiding the pitfalls of rushing forward, claiming we know how to control weather and climate. History matters. It matters a lot. After all, today's science is tomorrow's history of science. Let's try to avoid contributing to a checkered history. Thank you very much.